Hi everyone. In this lesson, we will be reviewing two of our geometry topics from the year, logic and parallel lines with those transversals. So the first thing we're going to do is just kind of review the topic a little bit, and then we'll be able to do some practice problems. Those practice problems are going to closely mirror the end of course test, so they'll be good for us to look at. Let me grab a pen here. So with logic, we dealt a lot with conditional statements. Conditional statements. So a conditional statement is one that's in the form of if and then. And each of these pieces, you might remember this from science class, has a name. So the first part, the if part, is the hypothesis. And the then part is the conclusion. And these sentences obviously can vary, right? We can put anything in those blanks. Like, if I study for the test, then I will do well. If I eat lots of green beans, then I will be healthy. Things like that. And so because we can fill these blanks with anything, essentially, we oftentimes give them labels instead. So that way we can work with it without having to rewrite the whole sentence. So we will usually assign P to the if part and Q to the then part. So P, then Q. And it's so funny. I have no idea why they chose P and Q. I'm guessing it's because all the other letters were taken. Things like M is slope, B is y-intercept. You know, they had to find some letters that were not taken for something. All right, so then we can go ahead and manipulate this in 4 different ways. The first way is the converse. And I like to remember that by thinking of the reverse. So the converse is the reverse. All you do is you flip the parts. So instead of P implies Q, it will be Q implies P. That's kind of how we read this little arrow here. We say implies. The inverse, you make them opposite. Basically, you not them. We're going to talk about that a little bit later too. Not has a very special symbol, and it's the little squiggly line or the tilde. But the inverse alone is just that you make them opposite. So it would be not P implies not Q. And every time we talk about these statements, we go back to the original conditional. So I made P not by adding the squiggle. The contrapositive, you do both of these. So you flip them and make them negative. So it would be not Q implies not P. And lastly, we have the biconditional. So the biconditional oftentimes is the if and only if. I say oftentimes, but all the time. What I meant by oftentimes is you'll see it written like this: P if and only if Q, or P double arrow Q. You can only write the biconditional if the conditional and the converse are true. So the original statement and also the flipped, and that makes sense, right? Because this is telling us that the statement is true both directions. That's what that sort of double arrow means. So in order for us to be able to write a biconditional statement, the converse and the conditional have to be true. The next review of logic, we had 2 laws, the law of syllogism and the law of detachment. So again, we're going to use those P's and Q's. Here is the law of syllogism. If P implies Q and Q implies R, therefore, we use those 3 dots for therefore, P implies R. And this is kind of like the transitive property. Remember, if A equals B and B equals C, then A equals C, right? These 2 parts match, so we know A must equal C, just like this. These 2 statements match, so we know that P must imply R. And our law of detachment says P implies Q, and then P, therefore Q. So this means if P implies Q is true, and P alone is true, then of course Q has to be true, right? Those are our two laws. And I think this is the last slide, I could be wrong, where we're going to talk about some topics before we get into example problems. We have two types of reasonings, and this reasoning, you guys do it all the time, just on the regular, on a daily basis, but we're just giving it some names. So inductive reasoning is when you take a very specific observation, and after making specific observations, you make a big general statement. One example I'm thinking of is I just got a bunch of fruit at the store and I put in this big bowl. And my daughter grabs a piece of fruit out and she gets an apple. And then she grabs another one and she gets an apple. And she goes, Mama, are these all apples? So she was using the two specific observations because she couldn't see what was inside the bowl. She was like reaching. She used those two specific observations to make a statement. All the fruit in the bowl are apples. So the thing about this is that logically it's true. Like she was making a really good logical argument, right? Like, oh, I did it twice and I got an apple. Maybe I do it 3 times and I get an apple. But you can imagine what might be wrong with that. What if there are 3 apples and 3 bananas and she just didn't reach them yet? So it's logically true, but it might not be realistically true. You just kind of have to keep that in mind as you're doing your inductive reasoning because you're only making specific one-time observations. You could do it multiple times, and then some people say, well, when is it enough? And then you get into the whole statistics conversation about the validity of your data. So for us in geometry, we just want to be able to identify inductive reasoning and use it. So we're doing specific observations to make a big general statement. The other kind of reasoning is deductive reasoning, and this is the converse of inductive. That's where we start with a general statement. We take that general statement and we're able to apply it to a specific scenario. Take the fruit example. If I said to my daughter and I said, Lily, this bowl is full of fruit, right? There's my general statement. Then she knows when she goes to take something out of that bowl, a specific scenario, she's going to get a piece of fruit, right? She's not going to get a chocolate bar. She's not going to get a potato, right? She's going to get a piece of fruit. So she's basing her specific examples off of the general statement that I made. And these are always true because they're general, right? If I say these are all fruit, then they're all fruit. That's it. They could be different types of fruit, but they're fruit. All right, so let's do some specific end of course SOL type questions. Here's one that you might see. Which statement is the inverse of if the waves are small, I do not go surfing? So as you're taking your test on the computer, I'm thinking of the SOL. Some of you may or may not be taking that this year. It's just very specific to your case. I personally, up on the toolbar, I wish I would have snipped this for you guys. There's like a highlighter tool. I think it kind of looks like this. I would click that and I honestly would highlight some of those important words. Let me get my highlighter tool. I'm looking for the inverse. Because remember, this is going to be on the computer. So you're not going to necessarily have that paper in front of you. You'll definitely have scratch paper, but I don't guess that you guys are going to want to, rewrite this whole question. So definitely use those digital tools to highlight the important things. So we're looking for inverse, and we know the inverse is you make them opposite. So we know our original statements are P and Q. So for the inverse, we're looking for not P, not Q. So then it's sort of just like a matching game. So the first part of this statement, if the waves are small, that's P. So we're looking for if the waves are not small. See, that's how you make it not. So we want not. The second part, that's the Q. I do not go surfing. So you want to make this statement opposite. So you do go surfing. So we're looking for if the waves are not small, I do go surfing. Could be A, right? No, it's not that. No, it's not that, because the first part of the sentences don't match. Or it could be D. So we have those. P is correct. Let's look at the Q. We want I do go surfing. Here it is. They don't have the word do in there, and that's okay. You know, English language, this means the same thing. I do go surfing or I go surfing. The answer is D. Don't forget at any time, you guys can pause this recording to try these on your own and come back for the answers. So when you first see this problem, I don't know about you guys, but it looks like there's a lot going on. And when you come across a problem like this, I don't want you to immediately feel stress, because if we just look at it, you'll see it's fairly simple. They want you to we're basically matching, honestly. Look, they tell us to begin with that P equals Brent works this summer. So that's it. They're just saying they want you to let this statement equal P. And they want you to let this statement equal Q. So we're just giving labels to the sentences. So now symbolically represent the following argument. So this is one of those TEI questions where you're going to click and drag. It says click and drag the answers to the correct boxes. If Brent works this summer, well, see, we already know what that label is. That is P, right? Brent works this summer. So I would even probably take again, on your toolbar, you're going to have a pencil tool where you can draw on your screen just like I am. Or you could definitely sketch this out on your paper, at least these few sentences here. So then the second part, he will not take a vacation. So let's be careful here. They've thrown in the word not. So if you look, our original statement is Q. Brent takes a vacation. So if we want to make that not, then we just put the little squiggle. Not take a vacation. So that is P implies not Q. So you just go down here to the bottom. Here it is. Click it and drag it up into this box. That's it. So we're basically just taking these symbols, P and Q, that they've matched to these sentences and rematching them to these arguments down here. Let's try it. Let's keep going. Brent takes a vacation. Well, up here it tells us that's Q. So I'm going to click Q and drag it up. Therefore, so something we haven't talked about yet, or did we? We did. We already did talk about it. Remember, therefore are the 3 dots. So we know this last statement is going to have 3 dots in it. So it's not these. You can use your strike through tool and get rid of everything that you don't need. So it's up to these last 4. Brent does not work this summer. Well, working this summer was P, right? But we want not, so it'll be not P. Therefore, not P. Here it is. Click and drag. So I would like to say that this is actually very little geometry, and it's more, again, logic, and you're kind of just matching up those symbols that they made for those sentences. But anytime you come across a question that might look a little scary, just take a deep breath. Maybe you can think of me and in your head say, this won't be so bad, right? And just take it one step at a time, because it might not be as bad as you're initially thinking. And then hopefully in this case, I don't think it was. All right, what is the converse of the following statement? So again, a lot of people, you might look at this and be like, oh my gosh, this is algebra. I don't remember how to do this. A equals what? No, you don't want to get dragged into what it might be, because this is just asking for the converse. So we think of the original as P implies Q. So this part is P and this part is Q. Remember, the converse is the reverse. So we're just flipping the parts. So Q will come first. If A equals B times C, then P. We're just flipping that sentence. Literally, that's it. That's the answer. We just flipped the sentence. We didn't have to do any algebra. We didn't have to do any other math. It's just sort of testing and seeing if you guys know what the converse means and if you're able to manipulate sentences like that. So let's find the one if A equals, so it's not that one because it has a not in it. So, and it's not D, because there's a knot. We don't have any knots because converse is just the reverse. Here it is. The answer is B. All right, if an angle has a measure of 120 degrees, there's P, then it is an obtuse angle. There is Q. It says, oh, we have lots of converse questions. Write the converse of the conditional statement. So remember, the converse is the reverse. So we're just going to reverse the parts. If an angle, and I'm going to write this out, is obtuse, then it has a measure of 120 degrees. So it doesn't have to be exact language, but pretty much matching what the answer choices are. So we're looking for if an angle is obtuse to come first, right? The second part is now going to come first. So it might be A, it might be B, it's not going to be C, it's not going to be D. So now we just need to decide, is the statement true or false? So if an angle is obtuse, so it's an obtuse angle. That's the hypothesis. That's what we're saying. Okay, this is what we have. It's saying, well, then it has a measure of 120 degrees. Is that always true? No, right? You could have an obtuse angle and it could be 200 degrees. It could be 202 degrees. It could be, it doesn't have to be that. So it is false. All right, so if the hypothesis is true, then yeah, it could be 120 degrees, but it might not be. And actually, it wouldn't be 200 because an obtuse angle is bigger than 90 and less than 180, right? So it could be 91 degrees, 92, 121. It doesn't have to be 120. All right, if an equation has a degree of 2, call that P. I just like automatically do this. Then it is a quadratic. You might read this sentence and be like, what? I do not remember that. We did this in Algebra 1. You don't have to know what this means. It just wants you to identify the hypothesis. So remember, the hypothesis is the if part, the first part. So that's what we're looking for. An equation has a degree of 2. It is C. That's it. Okay, let's review parallel lines and transversals. So I'm going to put some parallel line marks here on our diagram. You might see them written as arrows like this or like this. But the problem needs to either tell you they're parallel or you need to be able to see those markings on those lines. So there's a lot of different angle relationships that come from this. We have some corresponding angles. Corresponding angles are in the same position. So we can look at angle 1 and angle 5. See how we have 1, 2, 3, 4. This is sort of a grouping. And 1 is the top left, and see 5 is the top left. So that's why we say the same position. So we could, and these are congruent. These are always equal. Angle 1 and angle 5. There's a lot more of these, right? Like angle 3 and angle 7. They are all in that same position, bottom left, bottom left. Angle 2 and angle 6. And then angle 4 and angle 8. And remember, these are congruent. These are the same. Next, we have our alternate interior. So the word interior means they are on the inside of these parallel lines. And alternating, they're going to alternate across that transversal. So 3 and 6, and they are also congruent, and 4 and 5. Those are our two pairs of alternating interior angles. You have the same thing for exterior. So you're going on the outsides of those parallel lines, and they're going to alternate across the transversal. So angle 1 is congruent to angle 8, and angle 2 is congruent to angle 7. Next are our consecutive interior angles. So those consecutive, you think of consecutive numbers. Consecutive numbers are numbers that come one after another, like 1 and 2, 3 and 4, 4 and 5. So these are angles that are sort of I don't want to say next to because that could be confusing, but here they are. They're inside, right? Interior, so they're inside those parallel lines. Angles 3 and 5, those are consecutive interior. Some call them same side interior because they're on the same side of the transversal. So you might see them written as same side interior. And those are actually supplementary. So angle 3 plus angle 5 is 180. And then angle 4 and angle 6 are also same side or consecutive interior angles. And then similarly, we have the same thing for exterior. So they're on the same side of the transversal, angle 1 and angle 7. Oh, we should not have, let me grab my tool here. These are not, there we go. You add them up and they equal 180. I don't know, I was in the mode of that congruent. Okay, and then we have angle 2 and angle 8. Same side, but on the outside of the parallel lines. All right, so now let's work with some of these. It says click on the diagram that shows the correct solution. The diagram represents the stripes used to mark parking spaces on a lot. Based only on the information given, this is a statement you guys will see frequently, and it's important because this means you can't make any assumptions. None. Which diagram could be used to prove, let's see, to prove AB, I'm going to write it over here, is parallel to CD. Remember, this symbol means parallel. And AC is parallel to BD. So let's just look at each case here. If you look at A, we could just ask ourselves, is AB parallel to CD? So we're looking at AB and CD. So we just looked at all the different angle relationships here for parallel lines. So this means we're looking for these pairs. We're looking for these relationships in order to prove those lines are parallel. So if you look at AB, there are no angle measures written on AB, none. So we can't assume anything. Remember, it's based on the information given. So because there are not even any angle measures on AB, we can't make any determination. There's not enough information to tell. So nope, A is not in the running. Let's look at C. We're looking at A, B, and C, D. So we do have angle measures on both of those lines. That's nice. We have this one and this one, and those are corresponding angles. The diagram is just drawn differently, but you guys can still see that those are in the same position, right? They're kind of both on the left bottom here, and they're congruent. So that's true. AB is parallel to CD. Perfect. Now let's check AC and BD. Remember, it has to be both. So, oh, look, AC has no angle markings on it. None. This is blank, this is blank. They're all blank. So just like A, we can't tell. We don't know anything about the angles that are on AC. So, nope. Let's go to B. A, B, and C, D. We do have some angle measures. And do they make sense? So these are consecutive or same side. And let's see if they add up to 180. Remember, that was the one pair that adds up to 180? It does. It does. So that's awesome. Those add up to 180. Let's check AC and BD. Ooh, we have an angle on AC, and we have angles on BD, so let's check. And sure enough, look, these are alternate interior angles. So yes, they are both parallel. Let's check D just to be sure. You look at D, oh, look at D. There are no angle measures on line AB, none. So check that out. 3 of the 4 options were not even possible to tell. So you didn't really even need to know any of the rules, essentially, to pick B. We did need to know, like, of course, you need an angle measure, right? You need to be able to compare that to something. And since In all of these cases, there were no angle measures here, no angle measures here, and none here. We couldn't tell anything. So B is the only one that even gave us enough information to decide. All right, 4 lines and 4 congruent angles are identified in the diagram. Which statement must be true? So ones like these, I don't know about you guys. Excuse me. I like to go through each one of them and sort of cross them out because we just kind of have to check it, right? So A says only M is parallel to N. So is M parallel to N? Let's look. So M has some angle measures on it and N has some angle measures on it. So that's good. We're going to be able to check. And sure enough, these are alternate interior on both of those. And those are equal. We know alternate, whether you look at look, MN and P or MN and Q, they both show alternate interior angles, just in different positions. And they're equal, and that's what they're supposed to be. So M is definitely parallel to N. So it could be A or it could be C, right? It's definitely not B or D. So let's see if P is parallel to Q. So let's go to P. They both have angle measures on them. That's good. So now you're kind of looking left to right, right? Or up and down. We're looking at these two angles and looking at M being a transversal and N being a transversal. So these are consecutive exterior. Remember, if we go back and look, where is it? Consecutive exterior angles are supplementary. They need to add up to 180. So, sorry, does 89.9 plus 89.9 equal 180? And hopefully you're immediately going, no, 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 it doesn't, because, we know 90 plus 90 equals 180. So let me just get, it's 178.9. So this is a very tricky question. You wouldn't round up to 90 because they gave you that decimal place. So they do not equal 180, so P is not parallel to Q. So it is A. Oops, my mouse. Okay, here's our next one. A diagonal walkway cuts through a park bordered by 2 parallel streets. The park department plans to add an additional walkway as indicated by the dashed line segment in the figure. That's nice, like a little shortcut. What is the value of X? So because they tell you you have parallel streets, that should sort of, light bulb moment you, ding, 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 and say, oh yeah, we did a bunch of stuff with parallel lines and transversals. So this walkway is acting as the transversal. See? Sometimes it helps to sort of redraw it in the basic sense. So we have 132 here. So if that's 132, then we know that one will be 132. Remember, those are alternate interior. Now, because we're trying to solve for x, so we know this is 90. Can we find this angle? Now that we have 132 here, we could do this. Look, these are on the same line. Remember, two angles that are on the same line, they're called a linear pair, or they are adjacent. And remember, these add up to 180. So to find this one, we would just do 132 minus 180, which is 48. The other thing you could do is you could recognize that, look, these are same side interior or consecutive interior. So 132 plus this, again, is going to have to equal 180. So you used your parallel line transversal knowledge, and now we can use our knowledge of the angles in a triangle. Remember, they all add up to 180. So we could do 180 minus 90 minus 48. And that'll give us this missing x degree. And I got 42. I thought this was a really neat problem because it combined the parallel lines with our triangle sum theorem. So you might see problems like this for sure, where they sort of combine topics. All right, this one says, I'm going to give you that angle 5 and angle 13 are congruent. That's the only thing you know for sure, that these two angles are equal. I really want a different color to make it pop. There we go. Which lines must be parallel? So again, we're just kind of going to run through the answer choices. R and S. So if you look at R and S, those two angles live on those lines and they're congruent, and they're supposed to be congruent, right? These are corresponding angles, 5 and 13. So yes, R is parallel to S. Let's check the other ones before we choose A. It's always a good idea. P and Q. Look, we know angle measures on P, right? Angle 5 and 13 live on P. We don't know anything about Q. They only told us this. So nope. P and R. So P and R are definitely not parallel. Why not? Look, P and R. I'm going to draw it over here. P and R are not parallel because they cross. And we know parallel lines will never, ever cross because they have the same slope. So that's not true. And Q and S for the same reason. Those are intersecting lines. So it is A. Here's our last example problem for parallel lines with transversals. Given that lines L and M are parallel, so now see, the diagram doesn't tell you they're parallel, but the description is telling you they're parallel. So I'm going to mark these parallel. Which of the statements is true? Wow, look, they give you 4 different statements with a bunch of different angles. So it might be helpful to get some colors going on. D, E, F, D, E, F, and E, B, C. E, B, C. Says that those are congruent. So is that true or false? And one way to sort of do this is to walk yourself through the picture. So we know this angle is congruent to this one, right? Because those are alternate interior. And this one is congruent to that one because those are vertical angles. But the highlighted purple, that's definitely not equal to any of these I've marked. It's supplementary to that. So no, they are not equal. All right, let's look at the next example. So ABC, ABC, and DEF. And again, you could walk yourself through this picture as well. Look, we know this is equal to this because those are vertical angles. We know these are equal because they're alternate interior. And then look, these are another vertical pair. They are all equal. Also, the highlighted angles are alternate exterior angles, right? They're outside those parallel lines and they're alternating. Yay, you found it. Let's check the other ones just to be sure. It's good practice and you have the time because you can always make a mistake. I mean, I've done it thinking something is true and maybe you find another one that's true and you're like, wait a minute, was it B? And you can just check yourself. So we have A, B, C. I'm doing C now, and E, B, C. Ah, are these angles equal? No way. One, they don't even look equal. But also, we know that angles that are right next to each other like this are supplementary. Those are a linear pair. Erase. Oops. Okay. So it's not C. D is B, E, F. B, E. Oh, that's a straight line. And A, B, C. So nope, definitely not. Right? That straight line is 180 degrees. Those are definitely not equal. So we were able to confirm that it is B. So if you find after doing this video that you might want some more practice on these topics, please just be sure to reach out with any questions or go to our resource section of our website. Bye, everybody.